Okay, welcome everyone to day 12 of Advent of Code. About to begin here. I'm doing this one again at midnight when it comes out my time. Problem is set up because this running here. I'll go ahead and run this, make sure. Input's ready. This is ready. We should be all good to go once this problem begins here in a second. Alright. With the submarines, subterranean systems subsisting suboptimally, that's a lot of S's. The only way you're getting out of the cave anytime soon is by finding a path yourself. Not just a path, the only way to know that you found the best path is to find all of them. Fortunately, sensors are still mostly working. You can build a rough mapping of the remaining caves, your puzzle input. For example, this is a list of how all of the caves are connected. You start in the cave name start, and your destination is the cave name end. And an entry like B means that the cave B connected to that. Okay. Your goal is to find the number of distinct paths that start at start and end at end. You don't visit them all, and don't visit all the small caves more than once. Your goal is to find the number of distinct paths that start at start and end at end, and don't visit small caves more than once. There are two types of caves: big caves written in uppercase A, and small caves written in lowercase b. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting multiple times. So all the paths you can find visiting a small caves at once. Given these rules, there are 10 paths to this example cave system. Oh. Start A to B to A to C to A and these. What is? Okay. Caves visited by that path are listed in the order they are visited and separated by commas. Note that in this cave system, cave D is never visited by any path. Wow, this is... Okay. Note that in this case system, cave D is never visited by any path. To do so, KB would need to be visited by one twice. Yeah, okay. Okay. How many paths to this cave system are there? So we're actually going to be going right back to where we were yesterday again with the... with our breadth first search. Essentially, it's going to be the same thing, just a little bit changed. To start this first, we need to build up all of the paths. So this is just going to be a map, I guess, we can do. Why not? Okay. So we're just going to have, I think this is the best, is just to do a map here of string to string. This is going to be the paths, hash map. Come on. No, import map, please. Thank you. I'll go through our inputs and inputs, and then what we're going to go ahead and do is we're going to do paths, put, I'm actually going to split this first. Path parts equals s dots. Let's just trim to make sure. It's not really necessary to trim it, but we're going to just to be safe. It's not that, it's this. And it's going to be 0 to 1. There we go. So there's our map. That should build this all up. Visit small case at most once. So basically we just have to go from start to end and visit. Okay, so what we're gonna do is, how do we do this? So there, obviously it's a breadth first search is what it is. I guess the breadth first search is gonna be, it could be recursive actually instead of doing breadth first. Could do it in that case. Actually, recursive might be better here. So it's called public. Let's return a list of strings. What is this asking for? The count. So we'll do just a list of strings. That's fine. This is going to be move. Call it move, I guess. I don't know. Or navigate. Sure. I don't know. It's going to take in. We'll make this just a public kind of lookup table. So it's going to take in the position, and from this position we're going to determine all of the paths that we can take to the end is what we're going to do for. But we're also going to need a list of visited. So we could have probably done this with the what we had the past few days with the bread first search, but we're going to do this slightly different in that we're going to do a recursion. So this is going to be calling navigate, and we're going to start at start, and it's going to be a empty list here, and we're going to get out of this, we're going to get all the paths it can take, and what we should be calling is just lap paths size. So this is where all the bulk of the work is going to be done. What we're going to do is we are going to get a list. Oh wait, this can't work because it's going to have the same key multiple times. So map won't work. So I guess we're going to need to make a class then. Sure. We'll call it just path. I did that. Public string start. Public string. And or no, let's do it this way. This will be easier. Well, not easier, but this will be better. We're gonna do paths. Wow. Get our default. This. That's not what I meant to do. Grab this and then add on this. Yeah, get our default. I think it's what it is. Because the default gets. Oh, I know why. This is happening because, yeah, sorry, I forgot this is how this worked. This gets called from the constructor. It's weird. Don't worry about it. I totally forgot how my code worked. There we go. We're good now. Okay. Okay. So now we can call .add paths parts. I just spent a lot of time trying to remember how my code worked. Okay. So now we should be good. So if I do this, well, if this was still there. So we should get it to where this will now put the size of it. I'm going really slow for no reason. Okay, we're working now. All right, so now let's navigate. What we're going to do is we're going to have this navigate list of string. This is going to be the paths, I guess. What can I get? A array list, please. Thank you. So here's me all of our paths. And then we're going to go on the paths and we're going to get this position. And so this is going to be for string, call this destination, I guess. This is where we're going to. Go to destination, we're going to do visited. We're going to go ahead and add this destination in just because I know this doesn't always work. Oh, this is paths to return, by the way. We're gonna have to ignore the uppercase, but for now this is fine. Add it, and then we're gonna go ahead and call paths to return. We're gonna set equal to navigate, I guess. Give it a destination and giving it visited. Yeah, and then we're gonna have to go. This is gonna be kind of to edit them all. This is not totally needed. I don't really need to do this. All right, let's just make this easier on myself. And and we'll just have it do this. So this is going to be int paths to go. Let's just leave it as paths to return. So it's going to be equal to 0. And every time, well, yeah, we're going to have paths to return be equal to what we get back, adding it on. No, just adding that on, right? Yeah. There's 1, 3, 1 path. It's gonna populate up, right? Well, I gotta like think about this here a second. No, +1. No, this is a 1. Sorry. That starts as a 1. Okay. Right. So this should work. The only thing we need now is we need to filter out all of the little ones. So what we need to do here is we need to check if destination it's only the lowercase letters is what we care about. So if we just do a char at 0, if it is greater than or equal to A, and less than or equal to Z, what we need to do is we need to check if visited contains this destination, and if it does, skip it. We're just going to continue, just skip this location. We don't want anything to do with it, so we can actually just go into here, because if you've already visited it, we don't want to visit it again. Should we add a check here of if paths to return is still equal to 1, meaning we have nowhere to go. This is dealing with if we have, in this case, the example, we get to this one, we're not going to go anywhere, we're going to go back to B, but it's already been visited, so we have nowhere else to go. So if the path is 1, we're just going to return, oh, and the, well, actually we'll just do if, check up here, if position is at the end, and just return 1. That should be what we need. I have no idea. Again, no pointer. With paths again, I thought I fixed this. It's because there's got to go, we got to also know the reverse of the paths. Oh. Okay, so this goes away, because we also need the reverse of every path. Gotcha, so when we do this, we also need to do this. There we go. 12 seems wrong. You know what if we did this? What if we did a list of strings? What if we did this? We can still do that. That's still fine. And then if we're the end, we just return, whoops, return a new array list. Because we have, oh, can I type end, please? End, holy. right, and then get rid of this. I'm gonna go through all of our paths, and what this is gonna give back is now a list of a list. So this is gonna be the subpaths of this destination. And what we have to do is go through every list on here. And do add to position 0, I guess. I don't know. I could just do this adding on to the end of it. Just add on to the end the destination. And then we just return this, don't we? Oh, sorry, to return. And then to return would get all of these. We would add all these on because these are the subpaths for this one path. Wait, no, this isn't done here. No. Sorry, I messed. No. I don't know if this is even. I don't know if this is any better for understanding wise. Because that's where we're going, and then we move it out here. Oh, I didn't copy it. Should have copied that bit of code. And then out here, go through all the to returns and add on this one here. Yeah. So now the only place I can get created is if we get to an end. So now we just need to filter out the empty ones because we don't want empty one to be returned. This should continue. Guys, all right, we're gonna run into the same issue here, right? Can I just, okay. Will that fix it? Okay, I was getting annoyed by that. Is this 10? So 10's right. Okay. This looks awful. I'll fix that later. So 10's right for that one. $19's right for that one. Okay, let's try our input then. Somehow this is working. Don't ask me how. Somehow this is working. Don't ask me how. The available paths utilize that you might have time to visit every single small cave twice. Specifically, big caves can be visited any number of times. So cave can be visited at most twice, and the remaining small caves can be visited. Wait, what? A single small cave can be visited most twice, and the remaining small caves can be visited most. However, the cave's name start and end can only be visited exactly once. Once you leave the start cave, you may not return to it, and once you leave the end cave, you may return to it. Now there are 36 possible. You can visit one of the small caves twice. Oh. What we can do So we do part 1, part 2. If we allow twice, what we can do is visited here. We would just not add it. We would do it once where we go through all of them with it out added. Well, actually, no. Because we could use this allow twice here. So what we would do, so this is, we can allow twice. Okay, well, it's going to be allowed twice and true. And then leave the to return. And then we'll go through this again after we add it. And you can't allow twice. Wait. No, you can't allow twice because, right, you can't allow twice because it's there, right. And this is still going to be allowed twice. So 413, if this still works. Oh, this should only be here. If it's allowed twice, the only time I should be running this. Really? Oh wait, no, sorry. This one's the only one we do if we can allow twice. Right, not this one. The other one. Because this one, yeah. Did we just do it somehow? No. Okay. So what we need to do is actually pull this off. We need to take this. This is going to be, and we need to remove the ones out of here that don't include it. So for int I equals to add dot size -1 while we are greater than or equal to 0, I minus list string should we just do another for loop? So we have a boolean remove equals true. So for string s and to add get I if s. So we're just looking for if it has it. So if s equals where we're destination to, right? No, not destination, where we're currently at position, right? Yeah. If it equals that, remove equals, nope. Remove is false because we have now visited twice in this case. We only want to remove the ones where we don't see this come up again. So now we can just check if remove, this wants me to break, right? Well, we can actually just not do this remove. We can just remove it here. We can just do to add remove. Oh, no, we can't do that, right? Because we have to have another breakout here. Or no, we don't. No, we can just do to add remove I. This will break out of there, and then we'll keep going. Okay. And so now we should have the edited version of now where it occurs twice. 42 is still too high. Better, but still too high. And it can't be and it can't be start. Hey, no, we're too far. 32. No. Wait, because I'm doing this backwards. I'm totally doing this backwards. I don't know why. Right, I'm doing this backwards. I don't know why I thought that this was supposed to be like that. Oh, if remove. There we go. Why I thought I could put that there, I don't know. 44, that seems right to be above again. Okay. So yeah, so I still have duplicates, so I'm guessing, or what I have found. So I still have duplicates, so I need to go through. I mean, I can do this the dirty way of just going through and removing them all. And just doing size -1. This, I guess, just do it this way. I mean, yes, I could play around with more. I'm sure I can make this more efficient, but let's just get it working for now. List string and to return. Oh wait. Oh, I can't do. Let's do it this way. Again, this is not pretty, but just go with it. You can just do a check here if L dot contains all from to return I if let's do list if L1 does not equal 1, just make sure not the same list. Oh my goodness. Yeah, this ain't pretty at all. L1 remove. Nope, no remove. Please give me the right answer. Give me 32. Okay, so we got 36. This is just ugly, but we got 36. Let's just try mine, I guess. I don't know. Yeah, we're gonna have, it's gonna be too slow, isn't it? I don't know if it's this. I mean, well, it has to be this. It's just, what if I move it? What if I just accept it? What if I move it out here? This isn't pretty. I wish I could figure out a way to not have these duplicates happen, but it works. It's not amazing to have these duplicates here. Oh, it finally finished. It took a really long time. I'm gonna be really sad if this is wrong. That's right. Okay. Well, unfortunately, I don't know. This is kind of where I don't know enough. I'm not good enough in this space. This had a problem. Yeah. I don't know. I'm getting duplicates in the first place. I feel like I'm just missing something. And it's late. I'm just kind of calling today just a loss for me. I got it right, but in terms of being able to go through and teach and whatnot, I'm just gonna have to go and take the L on this one. Hopefully, so you kind of enjoyed watching my process of trying to do this. Hopefully, to everyone who's out there learning to program, hopefully this shows you that we're all human and that we're not all going to get these. Even if you haven't programmed for a while, you're still not going to be able to understand all of them and kind of get them right, I guess. I mean, like, I got this in the end, but this is far from the best way to do it. Sometimes you can't do it all, so I would go through and try to explain what I'm doing, but I just don't feel like it's worth me doing it. I don't feel like it's a good teaching point for me, especially when I don't really understand this. So I'm just gonna call this there. I'm gonna put this up there. Feel free to comment below on what I could do to do better, or what's wrong with my code here, or if you have a better solution algorithm, let me know. But at any rate, that's day 12. There's been better. Hopefully day 13 goes well, but I'll see you guys tomorrow for day 13 at any rate. So thanks for watching. Peace out.